All right, now we're going to do some calculating of differentials. And let's start with just some differential formulas. If u and v are differentiable functions of x, then multiplying by a constant, the derivative of a constant times the function is the constant times the derivative. If you add two differentiable functions, then the derivative of the sum is the sum of the derivatives. The product of derivatives is a little bit more interesting. You have to use the product rule. It's u dv plus v du. And then for the quotient, again, you have to make sure v is not 0, but the derivative of u over v is v du minus u dv over v squared. This is, you should recognize this as a quotient rule. So pretty much everything we've done before applies now. Now let's look at the difference in a derivative and a differential. And you're going to see real quickly that this can get to be a little boring. I'm going to come over here and I'm going to take dy dx of my function x squared, and this is 2x. But the differential is dy, which is 2x dx. All right, let's do another one. Dy dx when y is 2 sine of x. Well, this is 2 cosine of x. That's the derivative. And the differential, dy, is 2 cos x dx. Okay, let's do purple. What about if you have, this is a uv situation, dy dx is cosine x plus x, derivative of cosine is minus the sine of x. So my differential, dy, is cos x minus x sine x. Now I'm going to need parentheses here, dx. All right, what about y is 1 over x? You're getting the idea here, aren't you? Dy dx is negative 1 over x squared. So my differential is just dx over x squared. And don't forget your negative sign. And finally, dy dx of 1 over x cubed is negative 3 over x to the 4th. So dy is negative 3 dx over, that doesn't look like good x to the 4th, does it? All right. Now, let's talk about finding the derivative of a composite function. You pretty much just do the exact same thing you've done with other composite functions. The derivative of the composite. I need to take the derivative of the sine, and that's cosine. I keep my argument. And now I need to take the derivative of the argument, my inside function, and that's 3. Now for sanity's sake, I'm going to write this as 3 cosine 3x, because I don't like the numbers at the end there. What about if we have this function? Did I put my, I wanted the differential, sorry about that. So dy is 3 cosine 3x dx. You need to make sure you answer the question asked. Don't make up your own like I just did. Now let's find the differential of this one. Dy dx is 1/2. Okay, this is the square root of x squared plus 1. Derivative of the inside is, of course, 2x. So the differential, that's going. So the differential is x dx over the square root of x squared plus 1. Now some people will insist that the x be completely to the right. It doesn't bother me as long as you're algebraically correct. All right, pause the video and restart it when you're done. Now, imagine you're trapped on a deserted island and you have nothing to do except measure the heavens. And you use Pythagoras' theorem and you discover you need to find the square root of something that's not a nice, easy function. What can you do? Well, the answer is you can use differentials for that. Because, of course, if you're trapped on a deserted island, finding the square root of an odd number or a strange number would be, of course, your primary function in life after a while, I guess. Let's see how we could use differentials. Suppose I have f of x plus delta x. We can approximate it with f of x plus dy, which is f of x plus f prime of x dx. Now, how would I do that to approximate, say, the square root of 16? Well, let's let my function, f of x, equal the main function, which is just the square root of x. And then f prime of x is 1/2. It's 1 over square root of x. All right. So, if f of x plus delta x is going to be approximately equal to f of x, which is the square root of x, plus f prime of x, which is 1/2 divided by the square root of x. So all I've done is I plugged straight in f of x and f prime of x dx. Now, this is approximation for the square root function. Suppose I want to find the square root of 16.5. If I let x equal 16, and then I can let dx equal 0.0, or not 0.05, how about just 0.5? So, when I do this, this becomes f of 16 plus 0.5, which is of course 16.5, is the square root of x, which is 16, plus dx, which is 0.5, divided by 2 times the square root of 16. Now you see, this is now something you can do in your head when you're stuck on a deserted island. So this is 1/2, 1/2, 4. So this is 4.0625. Now you may ask yourself, what does your calculator say is the square root of 16.5? And my calculator says it is 4.062019, yada, yada, yada. All right, so we can get pretty close here. Give it a go. When you're done, turn off the video, finish your homework.